Hello everybody, today we are going to talk about pointers. This topic is really very important and it might be at the beginning very confusing. And be like, hey, why do I need pointers? Don't worry, next lessons will show the usage of pointers. Look, right now we can create variables that can store numbers, strings, floating point numbers, but we still have one more value that we don't know how to store. This value is called address of variable. So when I have, for example, variable int var and it equals 5, that variable has an address that we can get by using the ampersand. The ampersand and after it the label of variable will give us as a result the address of variable, right? Okay, and now we need a variable that could store addresses. It is really a very important thing to know how to do that. You will notice the usage of that, something like that in next lesson, so don't worry. But right now we need to learn how to create something like that. And to create something like that, we are using the type that we want to point to, and then the asterisk, then the name of our variable, we call it p from pointer, and then the semicolon. This variable here can point, it means that it can store as a value the address of variable that the type is integer, okay? So for example, we can store that address here, right? We can do something like p equals address of variable. I can compile it, and as you can see, everything worked fine. Now we can send to the output, for example, p. And you will notice that both of the things the same, right? Both results are the same. So now we know how to store as a value address. So pointers are ordinary variables that can store address of variable, addresses of variables, right? Okay, now let's see how to get a value, but just by having the address. So here we have an address and here we have an address, right? If I want to get the value under the address, I can use something like that. The asterisk sign. The star, right? Here I can do the same. And now you will notice that we got in both cases the same value. And now you might be a bit confused, because here is asterisk and here is asterisk. The asterisk that is preceded by a type is used to just inform. That asterisk here is just used to inform about that this variable is a pointer. So it is a variable that can point to address of another variable, right? Okay. This asterisk here, that asterisk here, is used to retrieve, get value from indicated pointed area in our memory, so address, right? This guy here is not preceded by a type, okay? Remember about the differences, because they are really important. Okay. Imagine that this thing here is some kind of area of our memory, of our program. And right now it's free. When I do something like that, and I compile my program, I am reserving 4 bytes of memory, because I need 4 bytes for integer, right? Okay. And then, when I do something like that, I am reserving memory for a pointer somewhere. So for example, that place here. And then, when I do something like that, so I'm assign to P the address, I am doing something like that. So that guy here is pointing here. Okay. We can also assign the address in one line, right? Like that. So we can just comment that guy here and it will work also fine. As you can see, everything works fine. Okay. So as you can see, that thing, that notation, is giving the same result as that notation, right? Okay. So it means that we can change the value that is under the address just by using the pointer. Like that. For example, I will assign here now 20, and now I will send to the output the value of var, and then I will send to the output the value by using the asterisk and the pointer. Let's do something like that, so it will be easier to read. And you will notice after compiling that the value changed here, right? And we use the pointer to change that value. Great. We can also change the value by using, for example, still that guy. And you will notice that in both cases, both values were changed, because we are changing every time the value under the same address. Remember about it. Okay. Now you should notice that we can change where our pointer is pointing to. So for example, I can create another variable, for example a, and I will assign to it, for example, 20. And now I will do, for example, here, in that place here, I will do something like p now will equal to the address of a. So now that guy here is pointing to the address of variable a, not to the address of variable var. So now, when I use here asterisk, I will get the value that is under the address of variable a. And you'll notice that we have 20 now here. Okay? And again, now I can change the value here. And the value will change, and that instruction will change the value of that guy here. So I can send the output to see if it's working. And as you can see, the value changed like I told you, so I didn't lie. Okay, but sometimes we don't want to allow to change where our pointer is pointing to, where it is indicating to, right? When we don't want to allow something like that, we should create something what is called the constant pointer. In order to create a constant pointer, we should add here, in that place, the word constant. Now, we have to assign the address when we are creating a pointer, when we are defining it, and we won't be able to do something like that here. Now when I build it, as you can see, we can read here an error. Assignment of read-only variable. It means that we can't change here, something like that. But when the constant is here, we still can do something like changing the value that that pointer is pointing to. Okay? But we can't, of course, do something like that now. Okay. Let's maybe do something like that so you can read that later. For example, int p constant. Now I add also here the word constant. Now I will, for example, send to a, and I will now comment it. This is a pointer that has to be initialized when defined, because it cannot change after defining it, after defining the thing that it is pointing to. So address, right? You can't change the address it's pointing to. Okay. We can also create something like that. Constant int, and for example p2, and this time I can, for example, again send here, for example, address a, and this time we won't be able to change the value, because when we did it that way, you probably noticed that when we did it that way, we still could change the value here, right? We still could do something like that. But when I do something like that, I won't be able to change the value by using pointer. And sometimes it's really useful. Okay. So this is a pointer that cannot change the value that it is pointing to. Well, the value that is under address it is pointing to, right? But when we do something like that, we of course can change the address easy. We also can do something like that. Constant int and then again here, for example, constant, and this time this is a pointer that cannot change the value that is under address it is pointing to, and also it can't change the address. Okay? But don't worry, that things are not used very often if you don't understand it right now. The most important part of this lesson is that thing here, okay? Remember about it. And now we'll talk about something what might confuse you a bit more, but don't worry. Well, look, that see here in our situation is our pointer, right? And as you can see, it is also somewhere in our memory. And it means that we also need a variable that could store address of our pointer. Yes, the pointer also has an address. Exactly. Wow, now it's getting a bit more confusing, right? Don't worry. Bit and run. And now, let's do something like that. Integer, ordinary variable, right? And I will say to it, for example, that. Now I will create an ordinary pointer that will take the address of that guy here, right? And now I will send to the output the ordinary value var variable. And now I will send to the output the pointer. So this thing is address, right? As a result, that thing is integer value. And we also can send something like that. And this thing is what? This thing is integer value from pointed place. So in our situation, this ordinary variable, so it will be the same value as here. And now something new will send to the output the address of pointer itself, because it also has an address, right? Remember about it. Oh, and we can also send to the output the address of ordinary variable. And as you can see, ordinary variable is 10, the asterisk ordinary pointer is 10, so as I told you, everything is working fine. The address of ordinary variable is the same as address of ordinary pointer because they are pointing to the same place right now, right? And now, as you can see, the address of ordinary pointer is different because it has also address itself. Okay, so it means that we can create something that could store also address of a pointer. Yes, and this thing looks like that, integer. And now, we are creating now here two asterisks. And now we can call it, for example, a pointer pointing to address of pointer. Yes, I know it might be a bit confusing. And now I can do something like that, ordinary p. And when I do something like, let's send to the output. And let's see if that thing here is the same as that thing here. Let's see. As you can see, it's true. Now we can store the address of that guy here. And if I wanted to store the address of that guy here, because it also has an address, I would do something like that. But don't worry, situations like that are very, very, very rare. Okay? So, okay, that's all in that lesson. In next lessons, we'll talk about usage of that guys here. Yeah, I know it's confusing. Don't worry. Thank you very much.